चादरों के सिलवटें तुझे अभी बुला रही है बाबा पापा पापा पा तेरा कहाँ पे हाथ दिल को Hi guys, welcome back to the newsroom. It's me Yosh. को मेरे क्या पता Even they denote time. Is that how we do it? What's the syntax? Yeah. Given the integer date, you know, time. Given the integer date, you know, day, denoting the day number shown on the screen which day of the week. It is week starts on Monday and for values filter in 7 or and filter everything. Is that how we do it? Console Minami talakimashita. Mama. 2, 3, 4, 5, 6, 7. Mama. Minamino. Arigato gozaimasu. 34. Is it 5 or 6, 7? Monday, Tuesday, Sunday, Monday, Tuesday, Wednesday, Sunday, Monday, Tuesday, Sunday, Monday, Tuesday, Wednesday, Thursday, Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday, Saturday, Sunday, Sunday kana. Ikinar ba? Minamino. Minami te आया हूँ Minami को जाऊंगा Minami te आया हूँ Minami को जाऊंगा Minami te आया हूँ Minami को जाऊंगा let's switch. What do you do this? No. Should I read this? What is an array? An array is a linear data structure in which... Okay, we'll read it, okay? It's fine, it's alright. What is an array? An array is a linear data structure in which we store data and perform any operation. We can randomly access data in an array with the help of its index values. In other words, an array is a collection of similar types of elements, homogeneous. An array is a linear data structure in which we store data and perform any operation. We can randomly access data in an array with the help of its index values. In other words, an array is a collection of similar types of elements, homogeneous elements that have contiguous memory locations one after another. Arrays store the related information in adjacent memory blocks. If you need to access one or more than one element, the process of finding or performing operations I get that. Zero index, finding an array. What's that? As we already specified the array containing homogeneous data, so the above one is an integer as it contains integer data. Arrays can store numbers, string, boolean values, character objects, but once you define the type of values that your array will store, all elements must be the same type. You cannot insert different types of data in a single array. Arrays cannot store heterogeneous data. Now what it means, let's understand through the visuals. Oh, you're gonna do that? Oh yeah, well, creating an array, blah, 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 blah. You can create an array like that, finding an element in an array. What are strings? Memory is allocated instantly after the array is created. The memory is allocated instantly, and the array is empty until you assign the values. Okay, elements are located in contiguous manner. So the elements can be accessed very efficiently. Direct access 0, 1 constant time using its index values. Arrays are powerful data structure. The type of elements and the size of the array are fixed, and the type of elements and the size of array are fixed and defined when you created arrays store elements of the same type, homogeneous, inserting elements. Reach to the end of the array and insert the element. The insertion at the end of the array. Insertion takes constant time O1. We can also insert the element in the middle of the start, or the start of the array, but it's a bit of a complex process. Removing elements, reaching to the index and removes the element. The removal operation takes constant time. What are strings? Strings are like a series of characters stored in specific order. Each character is a string. each character in a string is assigned an index starting from 0. Oh, really? This means the first character is at index 0, the second character is at... Shut up. You don't care about that. I just do the loops. You cool hacker? What you mean? Eh? ありがとうございます。I know I'm making fun of it. But it's fine. Yeah. Do itashimashita. Given two integers low and high, return the sum of integers from low to high inclusive. Input 1 is low is 1 and high is 5. So 1 plus 2 plus 3 plus 4. Ada मैं कर दूंगा सब कुछ. Okay, is it a loop? For loop that I do that? You already have it though. Until low becomes smaller or equal to high. Alright, now. And or low goes plus plus. Return. What am I doing? Some we can start with there. いいかな? Some goes like, am I doing right? If we return the sum of all integers from low to high. So sum plus low. That is, we need to return it, okay? So that's the loop and like sum is 0, that is going to be 1, okay? 1, so 0 plus 1, that's 1, sum becomes 1. So here it's 1 now. Now that's 1, it go like it's 2 now. Okay, like we updated it. So 2, checking condition. 1 plus 2, 3. Yeah, that's gonna work. That'll work. It should work. Minami se aaya hoon, Minami ko jaunga. Minami se aaya hoon, Minami ko jaunga. Da 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 da. Minami se ayahu. Minami changa. That's it. Da 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 da. Okay. While loop. Psu. Psu. Sure. Given a desert D 0 to 9, find the sum of the first 50 positives integers that an wait a minute. Given a desert D 0 to 9, find the sum of the first 50 positive integers. Huh? So that's D1. First 50 positive integers. Integer is that ends with digit D. That ends with digit D. So 1, 1, 1, 1, 2, 1, 3, 1, like that. Oh, their sum is. Taramba, papamba, namna. I cannot do that. I cannot do that. I cannot do that. I cannot do that. Sorry. Until our day is find the sum of the first 50. How do you do that? That's 2. First 50 integers ending with 1 are 1, 11, 21, 31. Okay, I get that. I get that. What condition should I write? Find the sum of the first 15 positive integers that end with digit D. Multiplied by 10 plus D. What condition should I write? Wait a minute. Oh, where is while? Loop, 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 loop. Okay. Okay, until $50. Okay, I can just fuck it. I'm just gonna like that. Okay, until I is. I should start with 1 though. Okay, until I is smaller or equal to 50. It's gonna run 50 times, okay? So now Now, isn't it? Am I not doing it same like that? Ah, ちょっと待ったー。いやー。Wait a minute. Ah, shit. だー。おららおらー。いいな、いいな。D. D. Okay, D multiplied by I multiplied by 10 okay, D goes like D like my D like my D. I can give it a sum, you know. Sum like a zero, 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 the buckle like a ha mina okay. No, I should D it. Oh, wait a minute. Wait, what the fuck? D, okay? Some should go like D. That's a D. Okay, we have those. Sorry, did it wrong. Some start with D. Some is gonna start with D, okay? Then first, I is multiplied by that and sum. We do sum, okay? Not D. And multiplied by 10. And yeah, that's gonna do 50 times, and we're gonna get our D. Tarata tarata. Pa 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 para 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 para. Sorry. Oh wow. Your output is that. What the fuck is that? Expected. My output is that. What? E plus what? What is that? What is that? Oh, I need to. Mama, ちょっと待って。D. Wait a minute. This condition is wrong. Some should go like. D can become like D multiplied by 10. Okay, and we just sum. Okay, sum plus D. So okay, that's here. D is okay. D is 1. Okay, then 1 plus 1 is 2. Oh shit, that is not cool. I'm gonna initialize that. Okay, here D is sum is 0. Here it becomes 1. And D now it's 11. Oh, okay, over here it's 11. Goes 11. 0. Sum is 1 now. And it was 1 plus 11. That becomes 12. Oh, that's gonna work for sure. Oh wow, sorry. It's gonna work, okay? Damn, man. Shit! Oh shit! Okay. I don't know, man, how to do. But I think this condition is wrong. Shit it. So like fuck. If yeah, I cannot do this. Okay. I is equal to 50. Then break. That's it. It's gonna work. It should work. Wow! What the shit is this? Ah! 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 Okay, whatever. That's fine. Ta 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 da 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 ta 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 da 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 da. Da 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 da. Yeah, it doesn't look wrong there. Sorry. Iteration D is 1. You add D to sum, becomes 1. Then you do D. Now iteration 2, D is 10. You add D to sum. Sum becomes 11. Then you do D, D, D. I think I'm doing this. Plus it should be plow. Shada. Shoddy. Oh fuck, man. What's wrong with the door? Am I ending it before? I think it should go like that down over here. I'm running out of my stars. What the what? Ah, I think it should be like. Arigato. Arigato. I was sweating my ass. Sweating my ass. Can you sweat your ass? ケツやらってきな。खड़ा हूँ आज भी वही वो बेकरार है आहूँ आज भी वही दिल जो बेकरार है रे रा रे रा रे रा रे रा रे रा रा रे रा रा रे रा रे रा रा रे रा. Given an array of n elements, task is to reverse the given array. The reversal array should be in place. Oh. Okay. N is 5. What do I do with then? Function to reverse the array in place. The reversal should be done in place. Do not return anything from this function. Okay. Do not return anything. Okay, reverse. How do you do that? Given an array. Can you store like that? Can I use a for loop? I mean, I can use a map. I can use a map, right? But that's gonna create a new array. Whatever. Let's try to do it. Okay. 1 0 1 0 until I is array dot length I okay, so I just for this and okay. No. For I. Can I do like that? And minus 1. Well, I do not have any n though. What? Okay, I don't need the n. It's the array length, bitch. How about that? Zero. Goes like 0, 1. We have a 1 over here. She, no. I'm not sure if that's gonna work. Let's see. Wow, 5 5 5 5. Ah, sorry. Oh, I need to know. Oh, sorry. Yeah, what is that? What? Expected 5 is fine, 4 is fine. Why did he go to 4 again? Killed! Damn, I killed everything. What do you write? 4 each? Oh, fuck, man. Ugh. Oh, 4 each is like 4 each. Oh, fuckhead, man. Gotta look at alleles, LA methods, alleles, LA. I'm from LA. LA method. Push, I can push it. No, I don't want to push it. I know. Okay, had those, okay. Now what I just do, so on the first, okay. I remove that, okay. Let me remove that. Array.splice. As I told you already that I'm a noob. Splice and then the start. But what you do there with this? How to delete an element? I do not need to delete. I do not want to delete it. No, I do not want to delete anything. Slice. It's much simpler than looking returns and suffer. Am I alive on the internet? Okay, not. No, I'm not alive. 이라서 하스테 시마스테. 수브레크 척된다요. Speed test. Punya baru, berlebar baru, berbagi baru. Kaishi itashimasu. Can you buy it? Can you buy these? Can you buy this? Arigato. 1 2 3 4 5 5 4 3 2 1 1 2 1 6 5 4 3 2 1. How the fuck am I supposed to do this? Guarda, नहीं आता दिमाग ही चलता मेरे तो ओ such a fool. I'm a fool, man. I'm a fool. What's up, fool? You fool in the market. Okay, let's do it again. Okay. That is my array. N is going to be, so N becomes here 5, no, 0, 1, 2, 3. N is 5, right? My N is 5. N is 5, then I start a loop, starts from 0. Okay. Five minus 0, what was that? 5 minus 0. So at the position 0, I'm going to delete. I shouldn't be deleting anything, boy. That's gonna make a shit. What the fuck? Yeah, that is not wrong. Yeah, that is so wrong. I shouldn't be using this shit. That is shit, man. Well. Daddy not you, oh daddy बना दो आप मुझे. Daddy बना दो आप मुझे too. Actual जाएंगे ना इधर पर. ऐसे कैसे होगा? 5 4 4 1 5 5. अरे क्या है जो? Bro, that's a simplifying version. I can't understand that. My AI is gonna raise me. And it's 5. 5 4 3. Now 4 5. Okay. Ah, shit. Yeah, that is true. Tries to remove one to the final spot. Where is it going to get it from? It cannot. It destroys. You destroyed your own data. Let's pretend you magically solved the data destruction problem. Figured how to properly swap the elements. Look at the low condition. You are iterating through the entire length of the array. If you swap the outer edges, then step inward and swap the next pair. What happens when you cross the middle? You will start swapping the elements back to its original position. Suffer. Tabada. Socket. How do you do that, man? I don't know. Step away from the keyboard. You cannot solve a logic. You cannot solve a logic by guessing some text. Think about the physical world. If you have a glass filled with water and a glass filled with milk, and you need to swap their contents, what do you do without pouring them into on the floor? I would use one more glass. Oh, wait a minute, I can just glass, extra glass. Glass, which is gonna have zero at the moment, okay? So glass over right space. Let's do it again, okay? I have an array 5. That's 5, okay? So my class is 0. Class is gonna store my this, okay? Class is storing this. Then fuck it. Fuck. So stupid. inside. Da, 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 da. Damn. Ah. Ah. You cannot override data in an array if you haven't backed it up first. You must create an array for the data from the first position into it. Or the data from the first position into it, okay? Move the data from the and of the array into the first position. Okay. From the and position to the first position. Okay. Okay. Yeah, I'm gonna go get some water, okay? I'll be back. I didn't know I was not audible, so. Link. I'll be back. Your face. Done. Mina, Mina, Mina. Be back! Oh god. Hey, Keanu. I'm gonna have a live coding interview tomorrow with some senior from Pune. Oh, really? Haven't live coded since, but I'm cooked. Sheesh. Bro. Interviews are very scary. Fuck, I remember like 4 days ago I had my first interview. Shit. Well, it was not a technical one. And I was sweating. Man. They are really scary. I'm not sure if you're here. Sheesh. Sheesh. Good luck. If you see that. Hi. Time and space complexity. What is time complexity? We can solve a problem using different logic and different codes. Time complexity basically helps. God fucking damn it, that's very hard. Okay, we can solve a problem using different logic and different codes. Time complexity basically helps to judge different codes, and it also helps to decide which code is. Okay. Time complexity basically helps to judge different codes and also helps to decide which code is better. In an interview, an interviewer generally judges a code by its time complexity. Now, the term time complexity seems that it is referring to the time taken by a machine to execute a particular code. But in real life, time complexity does not refer to the time taken by the machine. Time taken by the machine to execute a particular code does not refer to that. Does not refer to the time taken by the machine to execute a particular code. Let's understand why we would not judge any code on the basis of time taken by a machine. If we run the same code in an low-end machine, old Windows machine, and in an high-end machine, latest MacBook, we will observe that two different machines take different amounts of time for the same code. The high machine will take lesser time as compared to the low-end machine. So the time taken by a machine can be changed depending on the configuration. That is why we should not compare the two different codes on the basis of the time taken by a machine, as the time is dependent on it. Definition: the rate at which the time required to run a code. Okay. The rate at which the time required to run a code changes with respect to the input size is considered the time complexity. The rate at which the time required to run changes with respect to the input size. Okay. Is considered the time complexity. Basically, the time complexity of a particular code depends on given input size. So as the input size grows, the time taken by the machine also grows. Not the machine, not on the machine used to run the code. Basically, the time complexity of a particular code depends on the given input size, not on the machine used. Okay. So yeah, like the time taken by the machine to run the code, it is dependent on the size of the input, not the machine's specifications, machine itself. Let's understand this using the following diagram. Time taken and then input size. As the size is growing, the time is also growing. Now the next question that comes to our mind is how we will represent the time complexity of a code, as we are not going to use the standard units like minutes or seconds. So let's discuss it below. How we will represent the time complexity of any code. To represent the time complexity, we generally use the big O notation. The big O notation looks like the following. Time taken by a code inside the parentheses. Big O notation. Let's understand this using the following example. Given code for int Raj. Count. I think that's C++ code, right? Output console log. Yeah, the time complexity for this code will be nothing but number of steps. So that's n whatever. The time complexity for this code will be nothing but the number of steps. So there's O1. What is it? Just do it, man. This code will take to be executed. But the number of steps this code will take to be executed. So if we write this in terms of big O notation, it will be O number of steps. It is 5. First, the assigning step I1 will be done. Second, the step will be the comparison. Third, the third step will be the print statement, and the fourth step will be increment. In the fifth step, the updated value of I will again check the comparison and all that. In the sixth step, the print statement will be executed and so on. This flow will continue until the value of I becomes greater than 6. That means now, yeah. In a broader sense, we can observe that the for loop will run 5 times, and for each time 3 steps will be shortly executed: checking, comparison, printing, increment. So the total steps will be 5 multiplied by 3, 15. And the time complexity in term of big O notation will be O15. Now if we write n instead of 5, the number of steps will be then n3, 3n, and the time complexity will be O3n. But this manual counting process is not feasible for any code. as the for loop might run a billion or a million times, and inside that for loop there might be a large number of operations or some other for loops as well. So we have to find out a better approach to calculate the time complexity of a given code. Here come the 3 rules that we are going to follow while calculating the time complexity. We will always calculate the time complexity for the worst case scenario. We will avoid including the constant terms, okay, like this. We will also avoid the lower values. Avoid including the constant terms. Okay, sorry. Let's discuss the rules individually. Calculate the time complexity for the worst case scenario. If marks count grade D, okay, this one, okay. Before discussing before discussing the point, we need to understand the 3 terms: best case, worst case, average case. Let's understand these 3 terms considering the following piece of code. Piece of cake. Piece of ass. Okay. If marks best case is this, okay? This term refers to the case where the code takes the least amount. So takes the least amount to be executed. For example, if the mark is 10, then the first, okay, and this gets printed. Only the first line will be executed and the rest of the line will be skipped. So the least amount of steps, only 2 steps are required in this. Boom. In this case, this is an example of the best case. Worst case, this term refers to the case where the code takes the maximum amount of time to get executed. That's else one. For example, if the mark is 70, okay, the last line will be executed after checking all the above conditions. So the maximum amount of steps, 4 steps, are required in this case. This is an example of the worst case. Average case, this term is pretty self-explanatory. This is basically the case between the best and worst. This is, yeah. Now, as we always want that our system serves the maximum number of clients, we need to calculate the time complexity. Now, as we always want that our system serves the maximum number of clients, we need to calculate the number of complexity for the worst case scenario. With this, we can actually judge the robustness of any code or any system. To avoid including the constant terms, let's understand this rule considering the time complexity. O 4nq plus 3nq. Now, if we consider the value of n as 10 to the power 5, the time complexity will be like 4, 10, 5, 10, 10. In this case, the constant term 8 is very less significant in terms of changing the time complexity, which with different values of n. That is why we should avoid the constant terms while calculating the complexity. Okay. If we want to think of this case in terms of code, we can consider x is 2, I1 plus. Here the first step, this will be executed in unit time. Okay, and that's n. the precise time complexity is O3n 1 2 3 plus 1, but in this case the constant one is less significant, so we will not the 3, I mean, yeah, it's gonna run 3, whatever, you know. So we will write the time complexity as O3n, avoiding the constant term. Here the first step will be executed in unit time, constant time. The precise time complexity is O3n plus 1. But in this case, the constant one is very less significant. So we will write the time complexity as O3n, avoiding the constant term. Okay. Avoid the lower values. Now in the previous example, the given time complexity is avoid the lower values. Now in the previous example, the given time complexity is O4n cubed 3n square 8. And we have reduced it to O4n cubed 3n square. Here we can clearly observe if the value of n is a larger number, the second term 3n square. What? We can clearly observe if the value of n is a larger number, the second term will also be a less significant term. For example, if the value of n is 10 5, I don't know how you see that, square cube quadro pedro something like that. If the value of n is 10 to the power 5, then the term 3 multiplied by 10 to the power 10 becomes less significant with respect to 4 multiplied by 10 to the power 15. So we can also avoid the lower values. The final time complexity will be 4n. Ten to the power 5. That's 15, 4 and 15. And 10 to the power that. Oh, so we can avoid this as well. So we can also avoid the lower values, and the final time complexity will be O4n cube. Note, a point to remember is that we can clearly ignore the constant coefficients as well. Constant coefficients. For example, considering the time complexity O4n cube as ON is also correct. N cube. We can drop this as well. Oh yeah. Ignore the constant coefficients as well. For example, considering the time complexity O4n cube as ON cube is also correct. Apart from the widely used big O notation, there are several other notations among them. The two most common are the theta notation and the omega notation. The differences are shown in the below table. Okay, the big O notation represents the worst case. Big O notation, theta notation. Apart from the widely used big O notation, there are several other notations. Oh, who cares about that? Among them, the two most common are theta notation and the omega notation. Represents the worst case time complexity, the upper bound, and represents the average time complexity, the average time complexity. Represents the best time complexity, the lower bound. Worst, average, Who cares about that? Okay. Uh, these concepts are not much important for the intern. Very nice. Very well. Okay.